welcome back to Bihar Geek. So today we are going to solve a very interesting problem, that is partition equal subset sum. Okay, so the problem statement here says that we are given an array. Okay, and we have to return true only if the partition, if we are going to do the partition of the array in two parts. So in that case, whenever we do the sum up of those things, will get equal to each other. Like you see that in this example, it's returning true, because if we do the sum up of 1 5 and another 5, so it will be equal to 11, and there is another 11 is already present. Okay, so in that case, it's true only. And if we see here, if we try to participate in the way, like if we just do the addition of this, uh, so in that case it will be 5, but there is another one is there, either have to add this way. So whatever the permutation, if we're trying to do it, we are not able to achieve that the two partition will be equal to the particular number. So that's why it's returning false here. So I'm going to solve this problem. First, we will use the concept of brute force, where I will use the concept of recursion here. Okay. So let's get started. So first I will initialize one total sum. Total sum here. Okay. And we'll give an initial value. And now we'll check that the maximum sum what will we get. Okay. So for that I will use for n nums, which is equal to here, sum plus equal to number. Okay, we will get the maximum number from here. Now we have to check that the the total sum is odd. Okay, or not. uh, if we cannot divide it into the two equal thing, so it basically means that we are not able to achieve that answer. We just simply directly return the false from here. So if we put a condition, if total total sum to equal percentage to not equal to 0, it means the number is basically a odd number. So in that case, we are not able to participate into the two equal subset. So we just simply return a false from here. Otherwise, we will do return, and we'll keep the name as can participate. Okay, I use the name can participate recursion, and inside this I will pass the array, secondly the starting index, and next will be the total total sum from here, and will divide by 2. Fine. And now we have to give the definition for this. So let me copy this, and the type of this will be the boolean here. Okay, so private, and it will be the type of boolean and the name. Now we will need one array from here. We'll keep the name as nums, and there we need a index and the target. Okay, next we have to put a base condition first, that if the target is equal to 0, so simply we just return a true, that we got a sum. Target is equal to 0. In that case, we will return the true from here. Okay, otherwise we can run out of the element, or the target become negative. So in that case, we just simply return the false also. So we will check that if the index is greater than equal to nums.enjth, okay, or the target is negative. Okay, in that case also we will just return false from here. Next, we will return the recursion, and inside that we will pass the nums index plus 1, uh, index plus 1. Okay, and the target minus nums index from here. Okay, or we will pass recursion, or we have to pass it. There will be an or condition, and here I mean I'm just simply copying it. And see, command V, and let me terminate this. Instead of doing the minus, I'm just removing this from here. Whatever the condition is there, we will just simply return it. Let me run this. Okay, it's got accepted. Let me submit this. It's a beautiful solution, so it will, as you see that the time is exceeded, because we talk about the time complexity here. It's a n to the n, basically 2 to the power n only. Okay, and if we talk about the space complexity, that will be only O of n only. So we just need to optimize the solution. Okay, so we will use the concept of dpair. So first let me remove this from here. Remove this. So remove this also. Right. Now we again need a total sum. Right. That will be equal to 0. Now again we need a maximum sum from here. So int num colon nums is equal to num. Okay. So we will check that the sum is odd or not. If it's odd, so in that case we will just simply return a false condition from here that it's not possible. So we need to put a condition if total sum not equal to 0. In that case we just simply return the, or it's same like which we have did it in the with full solution. Fine. Now we need a target here. Okay, and inside the target we will like divide it by 2. So we will get a total sum, that what we will get it as a result in both case if we try to add the both subset. Okay, so if the total sum is like 6, so in that case the both subset should have a 3 values. Right. Now we will take a boolean here. Okay, and we'll name it as dp. Okay, it will have like dp tells whether a subset with the sum I can be formed or not. Okay, new boolean, and we'll target plus 1, the size of the array. Okay, now for the dp0, we'll keep it as true only. Okay, it's a base case for us because some 0 is always possible. Fine. Now we have to do a looping here, and I equal to our target. Okay, and I will be in the decrement order. It will go and I minus 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 from here. Okay, and then dp I will be equal to dp I or of dp I minus num from here. Okay, and it's done. Now we will return dp target. Fine, let me run this. I'm getting compiler time from. Okay, out of the illegal start of the type return. Why it's closing here? Okay, fine. It's okay. Okay, we forget to do one more thing. Uh, we need to add one more thing here. One more loop we needed here. Target we have started, and we have to keep it inside one more loop for end num nums. Okay, and it will take that number, and this way the loop will goes on. If given that name num, illegal start type. Which bracket I have missed? There is a one bracket. This bracket closes here, so we need this bracket also. So there would be two brackets here. Hmm. It is closing here. I missed something for this case. Okay, I forgot to add the bracket here. So it will close here. We have attempted one too soon. Okay, so there is a limit also. Fine. Let me till that time. Let me fix. Okay, and okay. Fine, it's got accepted. Let me submit this. So finally, it's got submitted also. So we have used the concept of dp here. That's why the complexity reduced from 2 to the power n to the n. N is basically multiplied by that the sum where we have done the sum divided by 2. The complexity is overall of n only. Okay, and if we talk about the space complexity, that will be sum divided by 2. Okay, and that's it for today. Hope you like this video. Thank you for watching. Bye bye.